So astronomers, after a while, studying Mars, after the initial speculation in the 1800s and early 1900s about what Mars was like and how Earth-like it was, by the middle of the 20th century had begun to realize that it was much less likely that Mars was going to be all that nice. Then realized that Mars was in fact a very dry world and unable to support life, unable to support liquid water at all. Unable to support life because unable to support liquid water. And so that was the general feeling here, based on the fact that the atmosphere is so thin that water cannot remain a liquid. But we were in for a big surprise. The Viking orbiters, as they were orbiting Mars, were sending back some of the best, highest resolution pictures that anyone had had up to that point, so the 1970s. And they sent back pictures like this. And it's like, oh, wait, what? And you look at this, and this sort of tree-like pattern here looks like tributaries. We call dendritic valleys. These look like dry riverbeds. They flow downhill. So they collect and then they flow into low things like craters or valleys or things. Some of these big craters actually have several what look like dry riverbeds flowing into them. And at the base of the riverbeds, there's like piles of debris down here, like stuff was washed down in there. And it's like, oh, wait, what? How can you get rivers on a world that can't have liquid water? And so this was a huge sort of conundrum. In fact, there are flow features around the Valles Marineris. And so we actually see outflow channels, debris fields washing out the bottom of the thing into the lower areas that are down there. And it's like, that doesn't make any sense if there's no water, because this is very clearly indicative that liquid water was flowing. There's also indications that near some craters, there's what look like mud flows flowing out from where the craters were, because the craters can release a lot of heat. Now, this gives us a clue for some of the water, because Mars is very cold. And so it's possible that any water that's there would sink into the ground and freeze, much like permafrost on Earth. The heat of the crater, the formation of the crater, the meteorite impact, would heat the ground and cause the mud to flow. But the question is, okay, that's fine for an impact feature, but what about all those other features like the dry riverbeds? Is there liquid water on Mars now? Well, there are some of these gullies running down from like cracks, in these cliffs, and different interpretations are that these cracks are evidence of gullies cut by running water, though some have indicated they might be caused by landslides instead. But this is suggestive that it is possible there might still be liquid water on Mars. Wait, I say might still be, because clearly, there had to have been a lot of liquid water on Mars in the past to give rise to the features that we see. And so what about now? Now, I'll get back to that later, because this turns out to be a big deal as to what has happened. Mars Odyssey and Mars Express have been orbiting Mars, and they have found evidence that they were looking at concentrations of water. Now, that doesn't matter. This doesn't say exactly what form the water's in. We assume ice, but regions where there's lots of water. And especially in the northern hemisphere, we find enormous amounts. And so remember that low area to the north? That is very rich in water, probably ice, almost like a frozen ocean. Okay, and there's several other pockets here. Now, Mars Express, which is a European spacecraft, has also got a surface penetrating radar, which has indicated that they have found what appears to be pockets of possibly liquid water below the surface. Now, at the surface of Mars, the pressure is much too low to have liquid water, but under the surface, that's not the case. Under the surface, then you have greater pressure, and you might be able to squeeze have enough pressure that the water can be liquid. Okay, so again, Mars Express has found at least 3 places on Mars where there does appear to be liquid water. Okay, and most recently they found what appears to be sort of a pool of salty water in the southern hemisphere. And so this actually raises some interesting ideas, because this is one of the things we would look for with life, is to have liquid water. The reason that water is important to life is that life is basically very complicated organic chemistry, and so in order to do the chemistry, you have to be able to move the chemicals back and forth, and you need a solvent. Water is a natural solvent for organic molecules, and so liquid water, every life on Earth is required to have liquid water. You know, even life that lives in very frozen areas, inside the life form, the water is liquid in order to move the chemicals back and forth. We don't think you can get life without having liquid water. Now, once you get life, the life can possibly not make ice into liquid water, you know, inside of it, so you can live in frozen areas, but you need to get life started in the first place. Now, one of the big problems with liquid water on Mars is the air is too thin. So let's actually compare the atmospheres of Venus, Mars, and Earth. So on the left, we have the atmospheric profile of Earth. The lowest part of the atmosphere is the troposphere, and then we get high enough, you get the stratosphere. The stratosphere is caused by all the ozone in the upper atmosphere. That's O3, absorbing energy from the sun, blocking the UV. Then we get the mesosphere above that, and the thermosphere. Now, if you go to Venus, there is no separate stratosphere, because what happens on Venus is that you don't get all that oxygen to make ozone with. And so the atmosphere is going to be different. The atmosphere is so thick, you've got to get to much, much higher altitudes in order for the pressure to become reasonable. So at the altitude where you get an atmospheric pressure similar to Earth on Venus, at about that altitude, the pressure is about 1,000 times less than the surface of Earth. Now, on Mars, there's less gravity. Less gravity means it doesn't hold the atmosphere in very tightly, and so the atmosphere tends to puff out further than it otherwise would. It's super thin on Mars, but it does puff out more. That means the cloud layers are not confined just to the lowest levels. You get water ice clouds, you know, at the lower levels, and then the very upper levels, it's so cold that you get dry ice clouds. And then, of course, there's dust clouds floating around as well. Neither Mars nor Venus are going to have a stratosphere like Earth does, because neither of them have oxygen with which to make ozone. Okay. Atmospheric pressure on Mars is very, very low. At the surface, it's only 0.6% of the atmospheric pressure of the Earth, a little bit more than 100 times thinner. The atmospheric pressure of the surface of Venus is almost 100 times thicker. And so this is like these huge extremes between the two. And so you get high altitudes at Mars. The atmospheric pressure is very low. In fact, you know, you get up to close to the top of Olympus Mons, and the atmospheric pressure is very much like it'd be up in the upper part of the mesosphere on Earth. And you get up to you know, the upper parts of the Martian atmosphere here, or mid part of the Martian atmosphere, you know, what would be like the top of the stratosphere on Earth, and yet the pressure is close to what it is in the thermosphere on Earth. And so this gives you an idea as to just how thin Mars's atmosphere is. But this raises a question. Mars's atmosphere is not thick enough to support liquid water on the surface of Mars. So how could you have had water on the surface of Mars? Okay, what would have been required for there to be water on the surface of Mars? Where did the atmosphere go in the first place? Where did the water go? Is there still water there? Most importantly, how long did it have water? Was that water there for long-term time, or did it come and go? Okay, so these are the questions that we want to ask because they're very crucial to understanding the past of Mars and the potential for any life that Mars may have ever had.